This is section 7 of chapter 1 of geometry. And so what we're learning about today is midpoint and distance in the coordinate plane. So we're going to talk about the midpoint formula and the distance formula today. Our objective is to find the midpoint of a segment and to find the distance between 2 points in a coordinate plane. So, first example is we're playing a video game and you got these two ancient structures that are shooting light beams at each other. And so when they shoot these beams at each other, a portal forms. And the portal forms halfway between them. And so if we're looking at our two structures, they're here they are. And so halfway between those two, if I had to guess, well, I'd say halfway looks to be about right. Oh, that's not going very well. Halfway looks to be about right here. Alright, and so you got to figure out how you're going to move your blue dot, which is you, over to that midpoint. Well, it looks like you're going to go left quite a few. And so you're going to left 1, 2, 3, 4, 5, probably about left about 6, 6.5. And so how we found their answer and how we found the halfway point and stuff like that, there are actually formulas for this. And so let's start talking about some of these terms and some of these formulas. You can use formulas to find the midpoint and the length of any segment in the coordinate plane. And so what you need to know is the formulas. The coordinate of the midpoint is the average or the mean of the coordinates of the endpoints. And so what we do in this example, we took the coordinate point of A and the coordinate point of B, we add them together and we divide by the number there are, 2. And that'll give us the midpoint. Now in the coordinate plane, there's a few more steps. The coordinates of the midpoint are the average of the x-coordinates and the average of the y-coordinates. You actually need to do this twice. Because in a coordinate plane, A here has two values. It has its x value and its y value, and B has two values, its x value and its y value. So your midpoint needs to have two values, its x and a y, and so it's the average of the x values and the average of the y values. So let's do some problems with this. We have a line segment AB and it has endpoints at -4 and 9. And so remember, to find the coordinate of the midpoint, we add them together. So -4 plus 9, and we divide by 2. So that gives us 5/2, which equals 2.5. So that's where our midpoint would be. And now when we're working in the coordinate plane, we've got to do a little. In the coordinate plane, we need to do this twice. And so we're going to do our x-coordinates first. And so we take our x-coordinates, E is 7, F is 2, 7 plus 2, and we divide by 2. That gives us 9/2, which is 4.5. So that's the first part of our coordinate, 4.5. And now we do the same thing with our y values. 5 plus a -4/2. That equals 1/2, which is 0.5. So you have 4.5, 0.5. And so if we go onto our graph now, we look, here's 2, 3, 4, 4.5, 0.5. That's about right in the middle of that box. Yeah, right there. So that's using the midpoint formula. And so what you're going to do now is, here are two problems I want you to do. For JK at endpoints at -12 and 4 on a number line, what's the coordinate of its midpoint? And for RS with endpoints at 5, -10, and 3, 6. Pause the video here and do. I got -4 for the first one, and the ordered pair 4, -2 for the second one. If you want to check your work, pause the video here and look at what I did compared to what you did. Alright, so sometimes we're given one of the endpoints and the midpoint, and our job is to find the other endpoint. So for example, we have this graph. We have the midpoint CD is at -2, 1 right here, and one endpoint is at -5, 7. And so to find the coordinates of the other endpoint, D, we're going to work backwards a little bit. So we know that for our endpoint, for our midpoint, the ordered pair is -2, 2, 1. And so we know we can use that formula to find some of these. So for the formula, your x1, which is that -5, plus your x2, which is that missing coordinate, divided by 2 must equal -2. So if we take the time to solve this, we're going to multiply both sides by 2 over 1, 2 over 1, 2's cancel out, -5 plus x2 equals -4. We add 5 to both sides. We get x2 equals 1. So we have that first coordinate of 1. Now we do the same process with our y coordinates. Let's get a little more space there. We know that the endpoint is 7 plus y2 over 2 equals the midpoint of 1. We multiply both sides by 2 over 1 to get rid of that divide by 2. We get 7 plus y sub 2 equals 2. Well, y sub 2 must equal -5, so our ordered pair is 1, -5. We look at our graph, that's all the way down here, and that is accurate. So you can give this as point D. And there we go. So I'm going to have you now do the same process with this next set of ordered pairs. You're down below, you're given the midpoint, so this is your midpoint, and you're given an endpoint. What are the coordinates of the other endpoint? Pause the video now and take the time to solve that. And so here you have that the other endpoint is at 11, -1. And so there we go. If you want to check your work, pause the video here, go back, look what I did, look what you did, compare. We're going to move on. So, for many real-life situations, you will need to be able to use the distance formula. So this one has even more steps, but it's pretty straightforward once you start to understand where it comes from. So here's the distance formula. The distance between 2 points, so these 2 points, the actual distance between them can be found using this formula. It's the x-coordinate minus the other x-coordinate squared plus y-coordinate minus y-coordinate squared, and then the square root of the whole thing. And so really where the distance formula is based on the Pythagorean theorem, which we are going to study later, which says that a squared, in a right triangle, a squared plus b squared equals c squared. And so we're going to actually find the distance. So what is the distance between u at -7.5 and v at 4, -3? So we're going to rewrite the distance formula. So distance equals the square root, of x2 minus x1 squared plus y2 minus y1 squared. So really all the distance formula, all the work you do is you just need to plug in values. So D equals, well, we're going to call this first ordered pair 1 and the second ordered pair 2. And so for the x2, we're going to plug in the x of the second ordered pair. So we're going to have 4 minus the first one, -7 squared, plus, well, the y of the second ordered pair, -3 minus 5 squared. So 4 minus -7 is the same as 4 plus 7. That's going to give me 11. So now I have 11 squared plus, well, -3 minus 5 is -8. So I have plus a -8 squared. Now if you find what each one of these are squared, 11 squared is 121. -8 squared is 64. 121 plus 64 is going to give me 185. So on your calculator now, take the square root of 185. Thing like 13.60147, etc. But if you go back to the directions, it says round to the nearest tenth. Remember, the tenth is one place after the decimal, and so we get 13.6. If you had to put your answer in a grid, like on the standardized test, you'd put it in like this. You'd 13, you'd start and you put the 1 in 3 decimal 6. So here is our final answer on that one. So what I'd like to do now, pause the video. You're going to do the same. You're going to do problems 3A and B. Alright, so now you've finished your problem. Check your work with mine. I ended up getting that it is 15.8 If you didn't get that, go back, look through my steps, look through your steps, make sure we agree. So that's for problem A. For problem B, we're going to scroll up a little bit to talk about this one. For problem B, it says, in problem 3, so the last problem we did, suppose you let V be x1 and y1, and U be x2 and y2. Do you think you'd get the same result? So let's look up here. So instead of having U be 1, you'd make V 1 and you'd make U 2. So I'm going to tell you that yes, right off the bat, you will get the same result, because if you switch this up and you did -7 minus 4, you're still going to get 11, but it's going to be a -11. And a -11 squared is going to be the same as 11 squared, which is 121. It's the same thing here. You're going to get then 5 minus a -3, which is going to give you a +8. +8 squared is the same as 64. So as long as you're keeping your x1 and your y1, your x2 and your y2 from the same ordered pair, it doesn't really matter which one that you pick in your for your ordered pairs. So let's move on to our last slide of the day. Here we have a zipline course, and so in the course you're harnessed to a cable that travels through the treetops. You start at platform A, so you start up here at platform A, and you zip to each of the other platforms in order. So how far do you travel from platform B to platform C? And so you went down from A to B, and then you're going to go up from B to C. They want to know how far is this distance. So first we got to know what those ordered pairs are. So B looks like it's at x of -30 and a y of -20. And C has an x of, each grid is 5, so that will be -15, 10. Okay, and so now we're going to use our distance formula to find those. So we know that distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So now it's just plugging and chugging. So d equals the square root. We're going to call this 1 and this 2. So we're going to put in -15 minus a -30. I almost goofed that one up. Squared plus a 10 minus a -20 squared. So now we got to do that arithmetic. -15 minus a -30 is the same as adding, so that's going to be a +15 squared plus, well, that's going to be the same as adding, so plus 30 squared. I gotta do 15 squared on my calculator. I don't have that one memorized. I think it's 225, yep. This is the square root of 225 plus the square root plus 900. 225 plus 900 leaves me with 1,125. If I take the square root of that now, that's going to leave me with 33.5. We're going to round it to the nearest hundred, so it's 0.541, so that rounds to a 5, so 13.5 is how far you travel between platform B and C. So there you have it. So I want you to now figure out how far do you travel from platform D to E. So if you go back up to our chart, D and E, here's D, here's E. Figure out that distance. Let me help you with the ordered pairs on those. D is at the ordered pair 20, 20. E is at the ordered pair 30, -15. So find the distance between those 2 points now. Pause the video as you find them. D to E to be 36.4 meters right there. Pause the video if your answer did not agree with mine. You can go back, check my work, check your work, make sure they find where we disagree. And that is the end of section 7 of chapter 1 of geometry.